Okay, so I am going to work on page 6 of the Unit 10 review. All right, 14a. For the exponential function, f of x equals 45 times 0.6 to the x, the number 0.6 represents, so the 0.6 is called the decay factor. So remember, it's 1 minus the decay rate gives you 0.6, so that total 0.6 is called the decay factor. 14b, for the exponential function f of x equals 150 times 1.2 to the x, the number 150, so that's the a, represents the initial amount, or the original amount that you start with. Okay, those are both found in lesson 3 notes if you need to look back. Okay, a couple word problems. 15a. Chicago Bulls playoff tickets have been sold out. As the playoff dates get closer, the price of a ticket increases. The cost for one upper level ticket was $65 yesterday and $71.50 today. Assume the cost of a ticket has been increasing at this rate and will continue to increase at this rate. So notice it's not saying it's going to go up by the same dollar amount, it's going to go up by the same rate of increase. Okay, so it's increasing. How much has the price of the ticket increased from yesterday to today? So they're just asking you the difference between yesterday's price and today's price. So yesterday it was $65, today it's $71.50, so it went up, it increased. So let's see how much. $71.50 minus $65 is going to be $6.50. So it went up $6.50. So that's the answer to part 1. So what is the percent of increase? Now, we did that a long time ago. So to find percent of increase, if you remember, is we found out how much it changed over the original. The change in the price over the original equals x over 100. We just found in part 1 that our change was $6.50. Our original is $65 equals x over 100. If I cross multiply that, so remember, I kind of did a butterfly, I get 65 times x, and here I get 6.50 times 100, so it's going to give me 650. If I divide by 65, I get x is 10. So my percent of increase is 10% increase. How much will the ticket cost in 9 days? So now I need a formula to figure out to answer this question. So I need an equation. So it's going up by the same percent, a continuous percent, or a constant percent. So that tells me that when it's increasing by the same percent, that I know it's going to be an exponential function. So I need to figure out my y equals a times b to the x. So a is the original amount, we just talked about that, or the initial amount. Okay, so I know my a is the initial price of the ticket, which was $65, but I have to figure out what b was. Okay, so my suggestion, I start with 65. So b is the original percent it was, so all of these always start at 100%. And then it's increasing, so it's going up, so plus, and it's going up by 10%. And I know my model is y equals a times b to the x, so here's my y equals a times b, I have to figure that out yet, to the x. So I have it all here, I just have to do a little arithmetic. So y equals 65, 100% plus 10% is 110% to the x. And then my last step is to change 110% to a decimal. So if I think of it as my decimal point is behind the 0, so I move it 2 places. So my equation will be y equals 65 times 1.10 to the x. Now I know some of you might do this by just starting with that formula, the 1 plus the rate. So if you did that, you would just be doing 1 plus 0.10, and that would give you 1.10. So you're going to get the same exact thing. I've just found my students thought it it was clearer or easier to write out the 2% and then change it at the end. So that's how we've been doing it. Okay, so the cost in 9 days will be when x is 9, y equals 65 times 1.10 to the 9th power. So I'm going to get my calculator out and type this in. So it's 65 times 1.10 to the 9th power. And that gives me $153.27. And I know it says 6, but remember the 6 behind it rounds it up to a 7. So the cost of the ticket in 9 days will be $153.27. Okay, so let's try another one. Matt has decided to sell his car. As each year passes by, the listing price or the price of the car decreases. Okay, so I know this one's going down. The listing price was $5,500 last year and $4,400 this year. Assume the listing price has been decreasing at this rate and will continue to decrease at this rate. How much has the price of the car decreased from last year to this year? Okay, so let's see. So again, I just want to figure out the difference. How much did it actually go down? So it was $5,500 minus $4,400 is $1,100. So the listing price decreased by $1,100. What is the percent of decrease? So just like this one, the percent of change, right? The percent of increase or decrease is how much it changed. So I do change over original equals x over 100. So the change is $1,100 over the original price was $5,500 equals x over 100. So again, I'm going to cross multiply. So I'll get 5,500 times x, or 5,500x, and I get 1,100 times 1,000. So 0, 0, 0, 0. So I get 11 with 4 zeros. So 1, 2, 3, 110,000. So I now need to divide by 5,500. Okay, so let's check to see what that is. So 110,000 divided by 5,500 gives me 20. Okay, so I know my percent of decrease is 20%. So my car is decreasing or depreciating or going down in price 20% each year. So how much will it be worth in 5 years? Well, I can't answer that yet because I need an equation. So I need to determine how much my car is going to be if it's going down 20% a year. So just like I did up here, it's the same idea. It's going to be an exponential function, and I know it's exponential because it's going down the same percent. So the same percent each year tells me it's an exponential. Actually, it's an exponential decay function. And I probably should have mentioned in this one, since it was going up, this one's an exponential growth function. Sorry, forgot that. Okay, so an exponential decay. All right, so I do my y equals a times b to the x, just like I did on that other one. Y equals a is my original or initial amount, which was $5,500. My car, or anything, always starts out at 100% of its value. And now this time it's decreasing, so I have to subtract off the 20% to the x power. So y equals 5,500. 100% minus 20% is 80%. And then I want to change that 80% to a decimal. So y equals 5,500. I'm going to move my decimal point 2 places to the left times 0.80 to the x power, or just 0.8 is fine. Okay, so here's my equation. And now I can use that equation to answer my question. What will the car be worth in 5 years? So I always know my initial starting point is when x is 0. So I want to know, what is this when x is 5? So y equals 5,500 times 0.80 to the 5th power. And that will give me 5,500 times 0.80. Remember, you can just put 0.8 is fine, to the 5th power. So it will be worth $1,802.24. Okay? All right, last one on this page. Gail has created a photo album of birds. She hopes to quadruple, so I'm going to circle that. She hopes to quadruple the number of birds that she has in her album every year. I'm going to put a box around that. She has a photo of 5 birds when she starts her photo album. Write a sequence that represents the number of birds she wants to have in her album each year. You must show a minimum of 4 terms. Okay, so she's going to have 5 birds when she starts. It's quadrupling, which means 4. I want to multiply by 4. So first 5 birds times 4 would be 20 birds. Times 4 is 80. 80 times 4 is 320. Okay, so we need to have 4 terms. What is the common ratio? Well, the common ratio is what we keep multiplying by, or 4. Does this represent growth or decay? Well, the sequence is increasing. So the sequence, I'm sorry, I'll try to print, I forgot. The sequence represents growth because the ratio is 4, and I know it's a growth model anytime my ratio is greater than 1, because the ratio is greater than 1. And you can also say, and the sequence is increasing. The numbers are getting bigger, they're not getting smaller. And the sequence, is increasing. Okay, I could have also said, instead of saying the ratio is greater than 1, this part right here, I could have said the b is greater than 1, because remember in the formula, the ratio is the b. Okay, all right, so that's the end of that page.